Hi, in this video, I'm going to cover two important topics, scatterplot and correlation, that are extremely helpful to understand the relationship between two quantitative variables. How does a scatterplot look like? This is a scatterplot of infectious rate on the horizontal scale and fatality rate on the vertical scale of different diseases from New York Times. A disease that spreads faster is on the right side, and the disease that is more deadly is in the upper side. Among these diseases, measles is the most contagious disease, and bird flu is the most deadly one. Thankfully, there isn't a disease that is terribly infectious and fatal. From this scatterplot, it appears that infectious rate isn't closely associated with fatality rate. At the time of recording, the whole world is still fighting against coronavirus. Because it is still unknown regarding how contagious and deadly the virus is, there is a box to represent its uncertainty. Therefore, a scatterplot can help us visualize the relationship between two quantitative variables on a Cartesian coordinate. The location of a point on the horizontal and vertical axis represents the value of each pair data. Typically, the explanatory variable or independent variable goes on the x-axis, and the response variable or dependent variable goes on the y-axis. Here is another scatterplot, which shows the age and the distance the driver can see from 30 drivers. As you can see, when a driver is older, the distance he or she can see is shorter, and vice versa. There is a negative association based on this scatterplot. On the contrary, this scatterplot shows the GDP and carbon dioxide from 10 countries. A country with a greater GDP tends to emit more carbon dioxide. Therefore, there is a positive association. It makes sense because when GDP is greater, there are more economic activities, which leads to more fossil fuel burning and therefore more carbon dioxide emission. A scatterplot shows the direction of the linear relationship, whether it's positive or negative, but it doesn't show its strength. A useful process to show both the direction and the strength of the linear relationship is a correlation coefficient R. It is defined in this formula. Imagine there are n pairs of data. The calculations start with the deviation of each value relative to the mean, which is the deviation after standardization for each pair. When both values are above or below their means, they tend to show similar behavior, and therefore the product would be positive. When they show opposite behavior, the product would be negative. After calculating the product of each pair, you sum them up and then divide the sum by the number of pairs minus 1. Here is the GDP and the CO2 data in the table. Let's use this example to help you understand the calculation step by step. Firstly, you need to know the mean and the standard deviation of each variable. The results are shown in 4 decimal places here to ensure accuracy in the end. For the first pair, the standardized GDP is 1.6 minus 2.31 divided by 1.2467, which is about negative 0.57. The standardized CO2 is about negative 0.46. The multiplication of the two negative values is positive, and here is approximately 0.26. If you repeat the calculation for other pairs, you get the result in the last column. Summing up the last column gives you about 7.94, and after dividing the sum by 10 minus 1, 9, and the correlation coefficient is about 0.88. It shows a pretty high positive association. Although it's not as complicated as it looks, in practice, people use software to find correlation coefficient. I have another video to show you how to get a correlation coefficient using Excel. Keep in mind that the common notation for correlation coefficient is R. Based on its definition, correlation coefficient is always between -1 and 1. Positive correlation coefficient means positive association, whereas -1 represents negative association. When the value is closer to -1 or 1, the stronger the linear relationship. When the correlation coefficient gets closer to 0, there is no or little linear association. This combines the knowledge of a scatter plot with that of correlation coefficient to match the 4 scatter plots with 4 correlation coefficients. The top left shows a clean downward trend, meaning when the x value increases, the y value decreases. This nearly perfect negative association should correspond to the correlation coefficient -0.91. Conversely, the top right plot shows a clean upward trend, therefore we have correlation coefficient about 0.88. In comparison, the bottom left has a less positive association, therefore we pair it with correlation coefficient 0.42. Because the data points on the bottom right don't show any linear pattern, the correlation coefficient would be near 0. To wrap up, you learn the idea of scatter plots and correlation coefficient to represent the linear relationship between two quantitative variables.